Hi, my name is Greg Batum, and this is question 5 from the Calculus 2 exam. So in this question, we have this integral of cosine x times cosine to the power of 5 sine x dx. Okay, this one's really wonky and weird because we have a sine x inside of a cosine, which is like mind-boggling. Well, let me just tell you that our first step is going to make this so much easier. Basically, we're just going to do u equals sine x. So that gets rid of the wonkiness here. But we still have cosine and cosine times each other, So the derivative of u is the derivative of sine x. So that's going to be cosine x. And you might think, oh, that just gets rid of this right here. And then, no. So we actually have to go and solve for dx here because we can have these values substituted, but we still have a dx on the end. We need to have the same variables in the equation. So we need to solve for dx. We're going to do that by just dividing by cosine, which is going to give us 1 over cosine x du. And this is what we're going to use to plug back into the equation. So now we're going to have from this equals cosine x times cosine to the 5u du divided by cosine of x. Do you see anything similar there? We have a cosine x on the top and a cosine x on the bottom. We can just get rid of those two. And that's going to give us the integral of cosine 5u du. Okay, looking a lot better. Now the problem is this giant wonky power of 5. Basically, we can't do that. We need to simplify the integral so that it's a little more workable. So we're actually going to pull a cosine out from here, and that's going to give us cosine of u times cosine to the power of 4 u du. Now we have this right here, and basically we can factor this. And you might ask, how can we factor this? Well, if you take cosine here, let's do cosine of u times cosine squared u squared. I just factored it. So basically, you just have to pull out the exponent and square it so that you can have the cosine times itself, which will give you cosine to the power of 4u, and then du. And this can turn into a trigonomic identity. So we actually have 1 minus sine squared u to replace cosine squared u, because we have the trigonomic equation cosine squared x plus sine squared x equals 1. We could just subtract sine, and that gives us cosine squared x equals 1 minus sine squared x. And that's how we can find the trigonomic identity to replace this cosine right here. And that's going to give us cosine u 1 minus sine squared x squared du. And you see that mistake I made? It's not an x, it's a u, because we are using variable u. So from this point, we are going to actually substitute again. And you might ask, why? Because we have to. And the way that we're going to do that is we're going to take a new single variable, v, and we're going to set that equal to the value of sine u. And then we are going to do the derivative of that, which is going to equal cosine u. And now we have to solve for du. Because we have a new variable present, and with one variable substitution, we have to have the entire variable, the entire integral equal the same variable. So right now we have cosine covered, we have this sine covered right here, but we still have this du right here. And basically what we're going to have to do is we are going to have to solve for du. And that's going to be very simple. It's going to be like what we did earlier, where du equals 1 over cosine u dv. Now, if we bring all of this over, we're going to do a little squiggly line right here so that I can work an actual problem. We're going to have integral of, let's see, cosine u 1 minus v squared dv over cosine u. And just like earlier, we have an identical numerator and denominator that we can cancel out, and that's going to give us an answer of 1 minus v squared dv. Okay, so we went from this to this. Now, what we have to do is expand this problem. So we have to take this square right here. We're going to bring it up again. Okay, lots of squiggly lines. So now what we're going to do is we're going to expand this by distributing. So we're going to have negative v 4 minus 2v squared plus 1. So this is going to be our problem right here. And did you notice the error that I caught, or that I made right there? So when we multiply a negative by a negative when we're factoring, this right here is going to be, let's see, negative v squared times negative v squared plus negative v squared times 1 plus 1 times 1. That's how we FOIL the problem. And that's how I got this answer right here. But when you multiply negative by negative, it cancels out and gives you a positive. So our answer is going to be the integral of v to the power 4 minus 2v squared plus 1. Okay, this looks a lot better. And since we have these minuses and pluses, we don't have anything else going on. Oh, I forgot something. We have dv right here. We can actually turn this into 3 different integrals by applying linearity. So we have v to the power 4 dv minus 2, we can pull that 2 out, so it's v squared dv, plus we can pull that 1 out, dv. So this is going to give us very simple integration. So we're going to have v5 over 5 minus 2v3 over 3 plus 1, nope, plus v. Okay, so now that we have this problem right here, we have the integration finished. We have 2 substitutions that we have to go back to. So first one we have is v. So we're going to do sine to the power of 5u. Oh, let's make sure that we didn't forget anything else. Nope. Okay. Sine 5u over 5 minus 2 sine cubed u over 3 plus sine u. Okay, so we have this. The problem is that we have to do another substitution. So now we're going to plug in sine x for u. So we're going to have sine to the power 5 sine x over 5 minus 2 sine 3 sine x. Oh gosh, I'm going to rewrite this. Put it all the way down here. Sine 5 sine x over 5 minus 2 sine cubed sine x over 3 plus sine of sine x. And we can't forget that constant at the end because it's an indefinite integral. So that's going to give us a final answer of sine to the power of 5 sine x over 5 minus 2 sine to the power of 3 sine x over 3 plus sine x plus c.